Hey folks, Mr. Dell here. We are looking at a two-column proof and kind of going through that process. We've been given the statement, so we just have to figure out the reasons, but we'll go through this process together here. So this is a problem that's coming from CPM's Integrated 2, actually, curriculum. So Integrated 2 CPM, and it's section 7.1.3, and this is number 7-39. So it's a proof. Let's read through what the problem says. So Penn started the proof below to show that AD if, so here's my statement, here's my given, if this and this, then this, right? So there's the proof. So this is the given part, right? And the given says if AD is parallel to EF and BF is parallel to CG, and by the way, that symbol means parallel. I'll write it out so you see it, parallel, when you see the two lines. So if those two sets of lines are parallel, then I want to prove, this is what I want to prove that A equals D. So that's my end, my beginning, my end. And this is the picture, this right here is the picture I'm going to go off of based on this work here. So we'll keep referring back to that. So the first statement says is AD is parallel to EF. Well, if I look, that was my given. So my reason is just simply that. It's the given. I also can see this right here in my statements that BF is parallel to CG. Well, once again, that's also a given because it was written there. So from those two statements, though, I'm going to be able to make some other statements and reasons. So let's look at that. So below the AF is parallel to AD is parallel to EH, which let me highlight those. AD is parallel to EH is what it says. So then it says once you know that those two lines are parallel, it says that A equals B. Which one's A and B? Well, in my picture here, A is this one and B is this one. Well, that makes sense because I would have to call this line here, this BF, that's my transversal, right? If that's my transversal, then I could say that A and B are equal because they are alternate interior angles. So our reason is if parallel lines, then alternate, I'm going to abbreviate alternate interior angles are equal or congruent. Okay. And then after this given, after the BF is parallel to CG, so let me re-highlight those. So BF is this one here. BF is parallel to CG. So it says what's true? B equals C. So which ones are B and C? B is this angle and C is that angle. And that makes sense if I've got those two lines parallel, then this line now right here is my transversal. And B and C are equal because they are corresponding angles. So we'd say again, if, let me rewrite that. If parallel lines, then, get sloppy with my then corresponding angles are congruent. Okay. All right, let's keep going. Now, why am I able to say A equals C? So here's my statement, A equals C. Well, if I look back what I just did, I just said that A is equal to B, and B, so I made these statements, is equal to C. So do you see how the B's here can be substituted, and therefore A is equal to C? So the reason is by substitution. All right, keep going. Why now can I say C is equal to D? So let's go look at our picture. Why C is equal to D? Which ones are C and D? So if I can see that. So C is this angle and D is this angle. Well, I don't need parallel lines in this case. I just need to show that I've got intersecting lines. Two intersecting lines always produce vertical angles. And what's true about vertical angles are equal. So all we have to write is vertical angles are equal or congruent. And then the last thing, how can I say A is equal to D? Well, if I have here A is equal to C and C is equal to D, right? Do you see that? So the C's can substitute each other, and therefore we can say A is equal to D. So we can go ahead and again, our reason is substitution. And now we're done. All right, there is our proof.